Astronomers are always looking at the universe and discovering new planets, stars, and other amazing things that blow our minds. Now scientists have recently found an incredibly bright and mysterious light that's nearly as old as the universe itself. But what is it that they found, and why is the light from this massive object so bright? In 2019, astronomers discovered a 13-billion-year-old light coming from a distant quasar. Quasars are massive and extremely remote celestial objects that emit incredibly large amounts of energy and typically look like a star when viewed through a telescope. But it is what lies at the heart of the quasar's light that's the most impressive. It's said that quasars contain massive black holes and may represent a stage in the evolution of galaxies. And what they found amazed and surprised everyone. A massive black hole that formed so early in the universe that it would have to have an incredibly huge solar mass amount, and mysteriously, it was created 100 million years after the Big Bang. It was given the indigenous Hawaiian name Paniuaena to honor its discovery from Mauna Kea. The quasar provides scientists with an idea of what the universe looked like millions of years ago. What can astronomers learn from this black hole? And what does this mean for the future of the universe? The name Paniuaena translates to unseen spinning source of creation surrounding with brilliance, and was captured by astronomers using the University of Hawaii's Institute for Astronomy's Pan-STARRS-1 telescope on the island of Maui. The nearly 6-foot diameter telescope is safely stored in the summit of Haleakala. It features the world's largest digital camera with almost 1.4 billion pixels and is a real treasure to employees at NASA. The data collected by the Pan-STARRS-1 telescope. But it took a lot more than just looking through a telescope to find this massive black hole. The W.M. Keck Observatory provided the near-infrared Echolot spectrograph to confirm the existence of Paniuaena. The over 32-foot optical infrared telescope includes a suite of advanced instruments from multi-object spectrographs to integral field spectrometers to a world-leading laser-guide star adaptive optics system. In addition to the near-infrared Echolot spectrograph, astronomers also utilized the GNIRS instrument in the Gemini Observatory. Once the presence of Paniuaena was established by both tools, scientists began to understand the incredible magnitude of this discovery. There's so much more to unveil with Paniuaena than any previous quasar. Quasars are known to give off an immense amount of light energy, but Paniuaena is especially brilliant compared to those spotted previously. A quasar found in 2018, known by the name J1342+0928, pales in comparison to both the glow and size of Paniuaena. Spectroscopic observations unveiled the black hole hosted by this quasar contains a mass 1.5 billion times that of the Sun. That's what makes Paniuaena especially unique. It's the only known object in the universe that has the capacity to host a black hole that's greater than 100 billion solar masses. This created another missing puzzle piece in the enigma that is Paniuaena. In order for this quasar to grow into such enormous power, it was most likely born approximately 100 million years after the Big Bang. This begs the question, how can the universe produce such a massive black hole so early in its history? Typically, a black hole of such size would grow from a smaller black hole that originated from the destruction of a star. However, Paniuaena disproves that such a theory is relevant in this circumstance and instead suggests that the black hole started off as a 10,000 solar mass seed black hole. The creation of galaxies and stars is believed to have begun during the epoch of reionization, around 400 million years after the Big Bang. The ionization of hydrogen gas led to the development of the first quasars and black holes. Before the epoch of reionization, there was no source of light present in the universe since radiation was typically consumed by hydrogen gas. Now, with the confirmed existence of Paniuaena, researchers have the opportunity to further explore the process of reionization to gain greater insight into the development of black holes. The quasar has been described as a cosmic lighthouse. As its light travels the long journey toward Earth, its spectrum is altered by diffuse gas in the intergalactic medium, which allowed researchers to pinpoint when the epoch of reionization occurred. The massive nature of this black hole is almost entirely incomprehensible, making it difficult to truly comprehend its significance. Scientists are able to calculate the mass of such a black hole by studying the movement of stars in the center of various galaxies. By evaluating the speed of these stars, we can understand the mass of the black holes themselves. These formations grow so large from absorbing immense amounts of gas over billions of years. They consume everything that crosses their path, and their incredible size creates more opportunities for them to swallow up any object in their gravity. As these objects are dragged into the black hole's pull, they're heated to millions of degrees, which results in glowing X-ray light. Nothing can escape the strength of a black hole's gravity. Nothing. However, scientists have only been able to spot a few young cosmos, despite thousands of galaxies existing in the closest universe. Since the illumination from the X-ray takes time to travel, studying these areas of the universe requires astronomers to virtually look back in time. There are two main theories as to how black holes are formed. One theory suggests that black holes originated from the first generation of stars. These stars, made up of helium and hydrogen, quickly developed into enormous beings that were possibly hundreds of times the size of the Sun. They did not last very long in the universe though, and their collapsed cores were all that was left after their inevitable death from titanic supernova explosions. Thus, a black hole was born from their leftover cores. The second theory works off the premise that black holes are not related to stars whatsoever. The first black holes were actually a result of unstable clouds of gas that eventually collapsed. This theory explains how the existence of gigantic black holes can be dated back to millions of years ago. Scientists continue to grapple with these two opposing theories, illustrating just how little we know about the origins of these great, bestial black holes. With the largest black hole in the known universe containing a mass 66 billion times than that of the Sun, known by the name Ton 618, the magnitude of these entities continues to baffle scientists. Fortunately, astronomers are not completely clueless about black holes in our universe. For starters, NASA has determined that it's impossible for a black hole to swallow up an entire galaxy on its own. Although their gravitational pull is quite powerful, it's not substantial enough to ingest an entire universe. No black hole is located close enough to our solar system to pull any object in, but scientists have studied what the potential consequences of falling into a black hole would be by observing stars. While stars that fall into their gravitational pull are ripped apart, humans would experience a process known as spaghettification. The strength of a black hole would stretch one's body vertically while simultaneously compressing it horizontally. Both the perception of time and space are altered when falling through a black hole. While outsiders would only be able to catch a glimpse of the exterior of the mass, the person experiencing the fall would suffer a warped idea of what reality means. With the Sun being the largest star in our solar system, some used to fear that it could explode and create a black hole that would inevitably suck everything into its gravity. But have no fear, the Sun is not large enough to explode and will instead become a white dwarf. Even the hypothetical explosion of this star would not create a black hole large enough to swallow the planet Earth. The Sun's gravitational strength would remain stagnant, meaning that our planet would continue to revolve around it as normal. While we do not have to fret about a black hole consuming Earth anytime soon, the creation of black holes undeniably affects all living things that reside on our planet. When black holes collide, elements such as oxygen and carbon are released into the universe. These elements can potentially contribute to the future creation of planets. Stars and entire solar systems can be formed by shock waves from stellar explosions that lead to black holes. The connection between black holes and galaxies is still unclear. Astronomers are not entirely sure whether the development of a black hole eventually led to the Milky Way galaxy, or if the Milky Way actually came first. However, it's clear that black holes did contribute in some way to our solar system, even if it's not entirely clear how. This means that everything we know and everything we are is due to the creation of black holes in the universe millions of years ago. Famous physicist Stephen Hawking determined that though the overwhelming presence of black holes is intimidating, black holes cannot remain in their massive states forever. Known as Hawking radiation, small amounts of energy are lost due to the nature of the vacuum. The vacuum is not actually ever empty, as particles are constantly entering and exiting. When a pair of such particles approach a black hole, one has the opportunity to escape as the other is sucked into the gravitational force of the entity. The energy that allows one particle to enter space and get away comes from the black hole itself, meaning that the black hole loses part of its mass in the process. Since this process is slow, black holes that make up the universe are expected to remain for millions or billions of years before shrinking. NASA has confirmed that while the black hole in the Milky Way galaxy seems threatening with a mass of a few million times that of the Sun, there is no chance of it consuming the planet Earth anytime soon. At this point, it swallowed almost all of the stars in its gravitational pull. Even if it's able to ingest a few more stars, it only has the capacity to grow in small increments. Galaxy collisions could potentially cause black holes to expand, but it's highly unlikely that these events would disrupt the balance in our solar system. Remember that Pathfinder is the second most distant quasar discovered. No matter how ravenous and powerful it may be, it remains very far away from Earth. Scientists have finally done what was once thought impossible. They captured the first image of black hole. But now that black holes have become easier to spot, researchers have found one hiding very close to Earth. Is it dangerous? Is it headed our way? Are there any other black holes out there lurking close to us? In case you're not familiar with these great devourers of the universe, black holes form when massive stars 8 to 15 times more massive than the Sun collapse after running out of fuel. Some create powerful supernovae that eject material outward in all directions at almost the speed of light. But some stars simply collapse into dark black holes without a supernova. During collapse, the core of the star begins to compress its gravitational center without ever stopping. The newly formed black hole becomes so dense that its gravitational forces become incredibly strong, pulling it into any object that comes too close. The forces of gravity in a black hole are so strong that even light cannot escape it. And now it's just been discovered that there's a black hole just 1,000 light-years from Earth. Located in the Telescopium constellation near Sagittarius, it's the closest black hole to the planet Earth ever found. By comparison, the black hole at the center of the Milky Way is 25,000 light-years away. This black hole might be too close for comfort. While 1,000 light-years might sound distant, in cosmic distances, it's very close. It's so close that you can see the star system without a telescope from the southern hemisphere on a dark, clear night with the naked eye. HR 6819 is a triple binary system that is made up of two stars that orbit a black hole. At first, it was thought that this was a simple binary system with just two stars orbiting each other. But after analyzing the data, something very unusual was found about the behavior of the inner star of HR 6819. The velocity of this star was so extreme that the astronomers suspected a third object must be sitting close, by which was flinging the stars around like a slingshot with incredible force. European astronomers finally found evidence for a mysterious, large, invisible object with a mass estimated to be 4.2 times the mass of the Sun by tracking the two companion stars using the MPG ESO 2.2-meter telescope at ESO's La Silla Observatory in Chile. To everyone's surprise, it was found that the two stars were actually orbiting a stellar mass black hole, around 25 miles in diameter, that was formed by the gravitational collapse of a star. The inner star, whose orbit is shown in blue, and the black hole in red look as though they're chasing each other. But they're actually orbiting each other. The inner star completes a loop every 40 days, while the outer star travels on a wider orbit. Is this black hole dangerous? Upon further study, the hidden black hole in HR 6819 was found to be one of the very first stellar mass black holes that do not interact violently with its environment, and therefore appears truly black. Is it moving towards us? While this black hole is really close to Earth in terms of space, it poses no harm to Earth at the present time, and is not moving through space. You may be wondering if there are any other black holes hiding out there, just waiting to suck up our solar system. The discovery of the black hole in HR 6819 so close to Earth is just the beginning, and provides clues about where we might find other black holes in the Milky Way. It's estimated there may be hundreds of millions of these universe eaters, and astronomers have spotted around a couple of dozen black holes in our galaxy. But that isn't the first time that a black hole has been found lurking close to Earth. But before we're able to directly image black holes, the only way they could be detected was if the black hole was feeding. This creates a ring of fire, called an accretion disk, that's caused by heavy gravitational and frictional forces compressing and heating the matter of a star or planet as it falls into the black hole. Before the black hole in HR 6819 was discovered, the next closest black hole to Earth was V616 Monocerotis, which is 3,000 light-years away. V616 Mon is around 9 to 13 times larger than the Sun, and previously you could only see this black hole because it's located in a binary star system that's close to a detectable star that moves in a unique pattern and is orbiting the black hole. Because it has a lot of mass, it has an incredibly strong gravitational pull. Cygnus X1 is another black hole that's close to Earth and is actually considered the first black hole discovered. It was first found in the constellation Cygnus in 1964. It's also famous because the late great astrophysicist Stephen Hawking bet another physicist that it wasn't a black hole. But Hawking lost the bet, and in 2011 it was established as a black hole. Cygnus X1 has 14.8 times the solar mass of the Sun, but only measures 18 miles wide. It lies about 6,070 light-years away from us, and is the most brilliant, high-energy X-ray source in the heavens. It spins at 800 revolutions per second and is sucking the gas from a closely orbiting supergiant blue star, which has a size of 19.2 solar masses and is 300,000 times brighter than the Sun. The gas heats as it's getting sucked into the black hole, forming an accretion disk and emitting bursts of high-energy X-rays and gamma rays through jets. Here's a video about what's happening with Cygnus X1 and the super blue giant. For a long time, we could only guess what a black hole must really look like, since it's nearly impossible to image an object that light cannot escape from. But technology has been advancing by leaps and bounds, and on April 10, 2019, astronomers obtained the first ever image of a black hole located in a galaxy called Messier 87. In the image, you can see the bright halo of gas surrounding the dark object in the center. But it's not just any black hole. It's a monster that measures 24 billion miles across. That's 3 million times the size of Earth, and has a mass 6.5 billion times of the Sun. It could quite possibly be the biggest black hole that exists. But thankfully this giant monster is 53.49 million light-years away, or 16.4 million passes from Earth. How the photograph was taken is an incredible feat. Scientists always thought they could image a black hole by capturing their shadows against the glowing surroundings. But this technology wasn't available until now. Everyone knows that the larger a telescope, the greater its ability to gather more light, and the higher its resolution will be. So how do you create the largest telescope in the world so it can image a black hole? A team was put together to take on this challenge and created a network of an array of smaller telescopes that can all be synchronized to focus on the same object in space at the same time. They call this the Event Horizon Telescope and have improved upon imaging faraway objects, which is known as the Very Long Baseline Interferometry technique. This new powerful telescope is as large as the distance between the two farthest telescope stations. One is at the South Pole and the other in Spain, which created an aperture nearly the same diameter of Earth, about 24,901 miles. This same team is now working on trying to image the supermassive black hole at the center of our own galaxy, Sagittarius A star, which is 4.1 million times the size of the Sun. However, therein lies a great mystery, because for some unknown reason, the ring of fire around the black hole at the heart of the Milky Way is smaller and dimmer. Since we now have the technology to directly image black holes now, there's a good chance we could find them hiding everywhere. There definitely could be a black hole even closer to us than 1,000 light-years. But black holes are still notoriously difficult to detect, which makes them dangerous because you don't need to be that close to be affected. A black hole can reach out through light years with its incredible gravitational forces, and if a planet gets too close, it could be obliterated, vaporized, or flung into an entirely new area of space. It's been discovered that black holes like the stellar mass HR 6819 can move. Rapidly moving black holes that are flying through space are essentially impossible to detect because space is very big. Could a black hole be heading our way? The truth is, no one would know until it might be too late. And if you can see stars being warped from a black hole, you're already too close. But for now, there isn't anything to worry about. In the meantime, if you want to try and find HR 6819, use a star map or star map application and find the constellation of Telescopium. It'll appear as a single bright object since the two stars are so close together. Of course, you won't be able to see the black hole itself, but you can know you're staring right at it. As technology and methods improve, closer black holes to Earth will inevitably be discovered.
October 4th, 1957. The first artificial satellite, Sputnik 1, was launched into space by the USSR.
Sending the first satellite into space was a breakthrough achievement for humanity and the beginning of a new era. It was also the start of one of the most iconic battles in history between two superpowers. It was the beginning of the space race. As most historians agree, the Apollo 11 moon landing on July the 20th, 1969, that put Neil Armstrong on the moon, put an end to the space race, despite the many successes that the Soviet Union had achieved. But soon, everything will change as the world starts a new race in space mining. Nations all over the world are thinking about mining the moon. China, India, Israel, the USA, Russia, all of them are trying to grab their own piece of the pie. Russia has already warned the USA against colonizing the moon, and now tensions between countries are rising. But is it really worth it? And just what is on the moon that is so precious? It's very possible that the moon could have large quantities of silicon, titanium, aluminium, water, precious metals, and helium-3. Today, we'll focus on helium-3 and why it's so important for us. Lunar missions from both the Soviet Union and the United States brought back lunar soil samples which were found to contain helium-3. The biggest reason we need helium-3 is that it could help free the entire world from dependence on fossil fuels. Having enough helium-3 could help us achieve clean energy produced by fusion power. The most important discovery was the unique atomic structure of helium-3 and that it could be used as fuel for nuclear fusion. A nuclear power plant uses a nuclear reactor to produce heat. The water surrounding the reactor boils, becoming steam, which in turn rotates a turbine that produces electricity. Current nuclear reactors are using nuclear fission, in which uranium nuclei are split apart. Besides releasing energy, this reaction is also radioactive, and the radioactive waste which is produced needs to be stored in special, secured underground stores. For more than 40 years, researchers have been designing a different type of nuclear reactor which could potentially provide an environmentally acceptable and safe solution to our long-term energy problems. In these reactors, light gases such as the hydrogen isotopes tritium and deuterium are used as fuel instead of uranium. And when the nuclei fuse, a stable helium-4 isotope, a neutron, and atomic energy are created. This reaction does not produce radioactivity and nuclear waste. But there's a problem with this procedure. The first neutron that's produced after the fusion is very difficult to contain and leads to a significant energy loss. This is where helium-3 comes into play. From a helium-3 and deuterium fusion, there is no extra neutron created. Instead, the byproducts are massive amounts of atomic energy and a proton, which is easier to contain and wastes less energy. And on top of that, the helium-3 deuterium reactions do not cause the surrounding material to become radioactive. Nuclear fusion reactors using helium-3 have the potential to provide a highly efficient form of nuclear power with no waste and no radiation. The building of the first fusion reactor has already begun, and in 2035, it's planned to be the world's first fully operational fusion reactor. So, we have 15 years to manage the lack of helium-3. But why do we need to go to the moon to extract helium-3? Helium-3 is relatively rare on Earth and is produced from the radioactive decay of tritium, a byproduct of the maintenance of nuclear weapons. But this isn't enough to supply us with what we need. In fact, helium-3 on Earth has a very low natural abundance and a very high production cost. Helium-3 is emitted by the Sun through solar winds, but our atmosphere prevents any of this from getting to Earth. Unlike Earth, which is protected by its magnetic field, the Moon has been bombarded with large quantities of helium-3 for billions of years by the solar wind. It's been estimated that there are around 1,200,000 metric tons of helium-3 on the surface of the Moon, down to a depth of almost 10 feet. This makes helium-3 100 million times more abundant on the Moon than it is on Earth. And since solar wind gases are weakly bound in the lunar regolith, it should also be relatively easy to extract them. Many scientists believe lunar deposits of helium-3 could provide us with all the power we need for 10,000 years. Researchers estimate that 25 tons of helium-3, which can fit in the cargo bay of one US shuttlecraft, could power the United States for an entire year. This means helium-3 has a potential economic value of about $3 billion a ton, making it the only thing remotely economically viable to consider mining from the Moon. The potential benefits of helium-3 are massive, and that's why the largest countries on the planet are planning to go to the Moon to helium-3. The United States' ambitious decade-long Artemis plan promises a human landing in 2024 and the establishment of a moon base that will allow long-duration crew stays for scientific, technological, and economic purposes by 2028. Furthermore, there is an aspiration for a gateway to orbit the Moon and serve as a jumping-off point for astronauts who want to explore Earth's natural satellite. This gateway is also envisioned to serve Mars missions in the future. This massive plan will entail 37 launches of private and NASA rockets and a mixture of robotic and human landers. In 2019, the US Space Agency awarded contracts to private space tech firms for the construction of a few of the first pieces of hardware that will be required for this colossal mission, such as the Gateway platform and the lunar lander. NASA wants to get back to the Moon by 2024 with its Artemis mission, which will cost $35 billion. That's almost 5% of the US military defense budget for 2020. The steep cost of this expedition has been met with skepticism regarding the goal of getting humans on the Moon by 2024. For now, the US Space Agency plans to put the first humans on the Moon before 2030. Across the Atlantic, Roscosmos, the Russian Federal Space Agency, has been very eager to show the world their ambitious plans for the creation of a lunar orbiting space station and a lunar base. Their plan includes developing a new super heavy booster that can carry up to 113 tons of cargo to low orbit and 29 tons to the lunar pole orbit. The Russian lunar orbit flight is scheduled to take place in 2029, and Russian cosmonauts will officially take their first steps on the Moon in 2030, while the construction of the Russian lunar base will begin in 2034. Unlike the United States, Russia does not see the potential for industrial utilization of the celestial body. Instead, they claim the role of their lunar station would be used as a defense against comets and asteroids. Not surprisingly, China has been heavily investing in its lunar program while also researching the possibility of lunar mining. Their program took off in 2007 when China sent off a spacecraft to orbit the Moon to collect data about the Moon's geography. By 2013, China successfully completed Stage 3 of its lunar exploration program by soft landing their first probe, Yutu. On January 3, 2019, China's second lunar rover, Yutu-2, landed on the Moon and is now scanning the Moon's far side. Incidentally, China was also the first country to grow a plant on the Moon inside the Chang'e 4 probe on January 7th. You can check out that video here, or you can find that video link in the description. In 2019, the Chinese National Space Administration talked about their interest in building a lunar base of their own on the south pole of the Moon in about 10 years, while also planning to send off their first crewed mission before this. The scale and timing of China's lunar program can only highlight Beijing's ambition to rival the United States and Russia as a space power. There's a big question regarding this. who really owns the Moon? The Outer Space Treaty was signed in 1967 by the United States, Russia, and several other countries. The Outer Space Treaty doesn't ban military activities within space, military space forces, or the weaponization of space. However, it does prohibit the placement of weapons of mass destruction in space, including nuclear weapons. It also limits the use of the Moon and all other celestial bodies to peaceful purposes only. It states that space shall be free for exploration and use by all nations, but that no nation may claim sovereignty of outer space or any celestial body. It's mostly a non-armament treaty, but has no real regulations when it comes to lunar and asteroid mining. Who will be the first to go to the Moon and successfully mine it? Only time will tell. For now, we need to understand the future, and that future is coming right now. In a decade or so, space mining will become a reality, and all of us will witness history being made. It'll be the beginning of a new age in humanity's history. Since the discovery of the telescope, astronomers have made huge steps into understanding the origin of the known cosmos. However, even after so many years, we're finding things in deep space that no one has seen before. On June 26, 2020, something mysterious occurred when 4 strange objects were identified by the radio telescope Australian Square Kilometre Array Pathfinder. These seem unlike any other astronomical objects ever seen before and ignited a spark of interest in the astronomical and space community. The first 3 objects were spotted in the depths of space using a pilot survey of a new project called the Evolutionary Map of the Universe, while the 4th object was retrieved in archival data which were collected by the giant meter-wave radio telescope in India and helped to confirm that the first 3 are not just lens anomalies. The object's distance from our solar system is still unknown, but one thing is certain: they're not located in the Milky Way's galactic neighborhood. Each object was calculated at around 1 arc-minute across, keeping in mind that, as seen from Earth, the Sun and Moon both have angular diameters of about 30 arc-minutes. The 4 unidentified objects are highly circular and with bright edges and look like distant ring-shaped islands. Because of their strange shape and peculiarity, they were characterized as odd radio circles, or ORCs for short. It seems that ORCs might have different origins. All of them were visible in radio wavelengths, but completely undetectable in visible light, infrared light, and X-ray light. 2 of them have galaxies at their center, which means that they might have been formed by them, while 2 of the ORCs might have some kind of interconnection, or even the same origin, since they seem to be in close vicinity. There are several possible explanations of what those ORCs might be, but none of them seem to fit perfectly the object's specifications and characteristics. The astronomers already ruled out a description for those ORCs objects like supernovae remnants, planetary nebulas, circumstellar shells, star-forming galaxies, or even the possibility of gravitational lensing. But the EMU survey is just beginning, and astronomers expect it to reveal more unusual objects as the time goes by. Speaking of strange space objects and unsolved mysteries, we don't need to go very far to find a celestial body to draw the astronomers' attention. If we look inside our very own solar system backyard, we will find Haumea, a dwarf planet which is found in the Kuiper Belt beyond Neptune's orbit. Why is it a strange planet, you're asking? Well, a day in Haumea lasts only 4 Earth hours, making it the fastest rotating large object of our solar system. Actually, it's rotating so fast that scientists argue that probably this is one of the reasons for Haumea's weird shape. This planet is not spherical, as you would expect any planet that respects itself to be, but instead looks a bit more like a football, since it's more or less twice as long in one direction as it is in the other. Haumea is 10 times smaller than Earth, with a radius of about 385 miles, and has 2 moons, Namaka and Hiaka. Due to its distance from the Sun, almost 43 times Earth's distance from it, one orbital period is approximately 282 Earth years. But a recent discovery made Haumea an even more interesting space object. It appears that this hobbit-sized planet's equator is encircled by a 43-mile wide ring of debris located about 620 miles from its surface. This discovery, in combination with Haumea's unusual features and the trajectories of several Kuiper Belt free-roaming objects, gave the astronomers a very good indication of what happened with this dwarf planet. According to a mathematical model, it looks like that a large Kuiper Belt object smacked at some point the younger and larger Haumea. The dwarf planet's ring and moons seem to be fragments of that collision, which also seems responsible for its fast-paced rotation. This is still a theory regarding Haumeas, but seems to fit the bill very closely. If we go a bit further, just a mere 20 light-years away from us, we can find the planet SIMP 0136 on the constellation of Pisces. This planet has given the scientists a good head-scratching, since it was discovered to have such a strong magnetic field that in an imaginary arm wrestling competition with Jupiter, SIMP 013 would win as if it was wrestling against an ant. You see, it has a magnetic field more than 200 times stronger than Jupiter's, which, as a reference point, has 16 to 54 times stronger magnetic field than the Earth. The planet forms the most spectacular auras, and astronomers don't really know the reason behind this, but hopefully we'll know in the near future. Furthermore, this planet is of even greater interest to the scientists because it's exactly at the boundary between a planet and a brown dwarf, or as it's also called, a failed star. This characterization means that this planet is quite large, at about 12.7 times the mass of our solar system's biggest planet, Jupiter, but not quite large to fuse hydrogen in the way stars do. Under further investigation, it was discovered that SIMP 0136 is actually a youngster brown dwarf of only 200 million years of age and is traveling the cosmos on its own without an orbit around a star. The scientists hope that SIMP 0136 will give them answers regarding the magnetic dynamo mechanisms of planets beyond our solar system, and that with the help of their radio telescopes, they'll discover more planets with such distinctive auras. One of the greatest problems in cosmology is that of dark matter. Well, this has nothing to do with black particles or any sinister type of material that destroys celestial objects. Dark matter, or as we initially called missing matter, is a type of material that cannot absorb, reflect, or emit light and cannot be detected by observing electromagnetic radiation. This means that it's extremely difficult to detect, and astronomers can only identify it by observing the gravitational effects that it has on other visible objects. One of the leading theories is that dark matter is made up of some new kind of subatomic particle that we haven't discovered yet. Even though undetectable, dark matter is extremely essential since it acts as the glue that keeps the visible matter of all known galaxies together. Astronomers estimate that dark matter accounts for 85% of the matter in the universe and about 25% of its total mass energy density. This is a lot, and it means that dark matter exists almost everywhere. Keep that thought for a second. In 2018, a team of astronomers announced that they have discovered the first known galaxy which contained an amazingly low amount of dark matter, almost zero. Its name? NGC 1052 DF2, or the more convenient DF2. This 10 billion years old galaxy is 6.5 million light-years away from our solar system and is more or less the same size as our Milky Way, but contains 200 times fewer stars. Because of that, DF2 is classified as an ultra-diffuse galaxy, meaning it has low luminosity and detectability. How did the scientists find out that DF2 has very little levels of dark matter? Well, we said that dark matter affects the movement of planets and other celestial objects. We know it's there because without it, there's no way of explaining the trajectories and velocities of planets and stars. This did not seem to be the case with DF2. And several star clusters inside it are moving at speeds in line with only the mass of the observable normal matter. After close inspection, it seems that DF2 contains at best 1/400th the amount of dark matter that astronomers had expected it to have. One other reason that constituted DF2 as an oddball galaxy is its shape. It doesn't have a noticeable central region or any of the characteristics of a spiral galaxy such as spiral arms or a disk. It doesn't look like an elliptical galaxy either, and there's no evidence that DF2 has a central black hole. just a stellar halo and several globular clusters. Everything about this galaxy seems strange and cannot be explained by any of the modern theories. The same team of astronomers quickly discovered another galaxy that shares the same bizarre nature in terms of low concentration in dark matter, with the name NGC 1052 DF4, or DF4 for short. Every galaxy we knew about before has dark matter, so you understand that these kinds of discoveries are a breakthrough that might help us understand the way dark matter-less galaxies work and get a firmer grip of the mysteries of the cosmos. In 2018, a dwarf galaxy nicknamed Bedin 1 was discovered in our Milky Way's space backyard, just 30 million light-years away from our doorstep. As a reference point, the whole observable universe is a humongous 93 billion light-years across, so you understand that this is extremely close to us. Bedin 1 is characterized as a dwarf spheroidal galaxy because of its small size, low luminosity, lack of dust, and its old stellar populations. However, this newly found galaxy is special in so many ways. First of all, it's tiny, just 3,000 light-years from side to side. In order to grasp how small this is, think that the Milky Way's famous spiral disk has a diameter of 100,000 light-years. Furthermore, Bedin 1 is approximately 2 million light-years away from any other bigger galaxy, which makes it the most isolated dwarf galaxy known to man. Lonely isn't a bad thing in the universe. It means that the dwarf galaxy hasn't had any interactions with other galaxies. But the most important is that Bedin 1 is calculated to be as old as the universe itself, more or less 13 billion years of age. And due to its isolation from any other galaxy, Bedin 1 is the equivalent of a living fossil from the early days of the universe. Who knows how many secrets this grandpa of a galaxy hides from us? Only time will tell. When it comes to deep space unanswered mysteries, one thing is for sure: we still have many spectacular things and objects to discover. Now a quick question for you, dear viewers. Now that you've seen some of the most strange celestial objects known to man, what do you think is lurking out there waiting for our astronomers to discover? There are hundreds of billions of planets caught up in the vast whirlpool of the Milky Way galaxy. From Earth, a lonely outpost floating on one of its spiral arms, humans have begun to peer across the void. And just recently, scientists have found the first Earth-sized habitable zone world. NASA's exoplanet program was created to find unmistakable signs of life on other planets. During the search for extraterrestrial life and Earth-like planets, NASA has found some incredibly bizarre alien worlds. We'll talk briefly about the planet's host star and the discovered Earth-like planets themselves. PSR J1719-1438 is probably one of the most fantastical cosmic objects you'll learn about here. The first thing to know is that 1438 is a neutron star, a small but incredibly dense stellar object which usually averages no more than 12 miles in diameter. Neutron stars are so dense that just 1 teaspoon of their stellar material would weigh about 1 billion tons on Earth. It's also a pulsar, which is a neutron star that emits strong beams of electromagnetic radiation from its magnetic poles and has intense magnetic fields, about 1 trillion times stronger than Earth's magnetic field. Some pulsars have an amazingly fast rotational spin, but 1438 is known as a millisecond pulsar that has a spin period of 5.4 milliseconds. That's about 10,000 rotations per minute. But we're talking about exoplanets here. And that's why the most impressive feature of the neutron star is its companion, 1438b, which has about the same mass as Jupiter, but is only about 40% the size of the gas giant. So what happened that made this planet so small and so massive? Scientists believe that 1438b is a remnant of a star that had its outer layers stripped away by the pulsar with its incredibly strong magnetic field. What's left is a planet that's composed largely of crystalline carbon, making this planet a giant diamond 5 times larger than the Earth, but with a density far greater than diamonds. Another incredibly mysterious planet is orbiting just 63 light-years away from Earth, which has been named HD 189733b. First discovered in 2005, its blue color comes not from the reflection of an ocean like Earth, but instead a hazy, blowtorched atmosphere containing clouds laced with silicate particles. This gas giant has daytime temperatures of 2,000 degrees Fahrenheit and 4,500 mile-per-hour winds. Under these conditions, it's speculated that it may rain liquid glass sideways. The planet is only 2.9 million miles away from its parent star, so close that it's gravitationally locked where one side always faces the star. By comparison, Mercury, the closest planet to the Sun in our solar system, is 29 million miles away. First discovered in 1999 and named after the transiting planets and Planetesimal's small telescope used to find it, TRAPPIST-1 is an ultra-cool red dwarf star that is slightly larger but far more massive than the planet Jupiter. It's about 39.6 light-years away from the Sun. The very first planet that NASA found that had a radius similar to Earth was Kepler 186f in 2014. This discovery confirmed that Earth-sized planets do exist in the habitable zones of other stars, and it signaled a step closer to finding a world similar to our own. In 2015, astronomers used NASA's Spitzer Space Telescope along with ground-based telescopes and found not one, but 7 temperature terrestrial planets that orbit the red dwarf. These very Earth-like alien worlds are mostly rocky, and some have the potential of holding up to 250 times as much water as planet Earth. These 6 planets could lie in the optimistic habitable zone and are so close together that if you were standing on the surface of one, you could see the other planets as moons. But the red dwarf star only puts out 0.5% of the energy of our Sun, and so the planets are dark and cold, and the star is about 5.4 and 9.8 billion years old. Many more planets are being discovered every year, and in early 2020, NASA discovered a planet the same size and same distance from its star as the Earth, about 13,000 light-years away. It was found using the microlensing technique and is very cold and likely has no life. It's known as an ice ball planet and is too far away from its host star, which some scientists are now saying may not be a star at all, but a brown dwarf. But even here in our own solar system, there's the possibility for life other than on Earth. The second largest moon to Saturn and the second largest natural satellite the solar system is Titan. It's the only other known body in space other than planet Earth where there is clear evidence of stable bodies of liquid. And usually, where there is liquid water, there could be life. Titan is a planet-like moon that is 50% larger than our Earth's moon and is 80% more massive. It has rain, lakes, and oceans, but is not exactly what you're imagining here on Earth. It's far more bizarre. We'll talk about that in a minute. Titan also has valleys, mountains, ridges, mesas, and dunes, some of which are ice-covered deep lakes from vicious winter storms because it's far away from the Sun and only gets 1% of the sunlight Earth does. So how does it have an atmosphere with rain, ice, and liquid surfaces? Titan is much colder than the Earth, with surface temperatures around minus 290 degrees Fahrenheit range, minus 179 centigrade. Although it sounds like we're talking about water, Titan's atmosphere is 98% nitrogen in 2% methane, and the seas and lakes are liquid ethane and methane. Even though its northern hemisphere is home to small liquid lakes, it's not really liquid at all. With these extremely cold temperatures, ethane and methane behave much like liquid water. However, Titan does have some warmth, and may have what's called a home-baked atmosphere. What we mean by this is that organic molecules are likely cooked by the moon's warm core, and the decay of radioactive elements may warm the moon from within. With all this in mind, is it possible that Titan could harbor some form of exotic life forms? That might sound a little bit far-fetched, but scientists believe that Titan's atmosphere could be the perfect laboratory for studying the organic chemistry that preceded life, which provided the building blocks for life on Earth. Deposits of organic material have been found in some parts of Titan, showing proof that this giant moon could host biologically interesting compounds, such as amino acids, which are the building blocks for all living things. Some scientists have regarded Titan as a deranged version of the Earth, and at the same time say it resembles an infant Earth in many ways before life evolved and irrevocably changed our planet. Titan's ocean sits below a thick ice layer and is believed to have favorable conditions for life, even though we're talking about life that exists in extremely harsh conditions. We already know of some life forms right here on Earth that can survive even in the vacuum of space, such as tardigrades, that can also survive minus 328 degrees Fahrenheit and temperatures as high as 300 degrees Fahrenheit. They can survive radiation, boiling liquids, and massive amounts of pressure, of up to 6 times the pressure of the deepest part of the ocean, without any protection. If this creature can exist in all these harsh conditions, there's no telling what kind of life could exist on Titan with its extreme environment. Some astrobiologists say that because there is a lack of liquid water on Titan's surface, there probably isn't any life there. But could life exist in Titan's methane seas? If life does indeed exist on the surface of Titan, scientists have agreed that it would be microbial, either very small in size or even single-celled organisms. But NASA thinks there's enough evidence for life and is planning to land a flying robot on the surface of the moon. We've already been to Titan before, with the CASSINI mission that almost everyone is familiar with. What most people don't know is that on January the 14th, 2005, Cassini jettisoned a small probe called Huygens, which made a spectacular film of its 2.5-hour descent into the surface. Huygens landed, surrounded by round blocks of ice, and saw dry shorelines, reminiscent of Earth, and many rivers of methane. The new mission is called DRAGONFLY, and will be the first endeavor of its kind. It's a car-sized quadcopter that is equipped with instruments capable of identifying large organic molecules. The Dragonfly is supposed to launch in 2026 and arrive at Titan in the year 2034. When the craft arrives, it will land near Titan's equator among dunes composed of solid hydrocarbon snowflakes. It'll be powered by heat from radioactive plutonium, much like NASA's Mars rover. But with its 8 rotors, it's going to be able to cover much more distance than any wheeled robot ever has. The Dragonfly drone will have to maneuver on its own, as light signals from Earth take 43 minutes to reach Titan, which makes the Dragonfly much more complicated to operate than a standard drone. The drone will use a specially designed navigation system that will help it to identify hazards and avoid them, and also be able to land autonomously. The AI that will be used on Dragonfly will be state-of-the-art. While in flight, the craft will sample the atmosphere and provide aerial images of the landscape. It'll then fly to multiple locations hundreds of miles apart, collecting data. But the ultimate destination is Selk Crater, which is the site of an ancient meteor impact, where scientists say they found evidence of liquid water, organic molecules, and the energy that could fuel chemical reactions. This will be the 4th mission to be funded as part of NASA's New Frontiers program, which supports medium-sized planetary science projects that cost less than $1 billion. And Dragonfly will cost around $850 million at the time of launch. As for the future of Titan, it could become warmer in 5 billion years from now, when the Sun becomes a red giant and starts the helium burning process. As our star expands, the outer layers will swallow Mercury, Venus, and eventually the Earth. But this changing Sun may provide hope to other planets or moons, such as Titan. Surface temperatures on Titan could rise to minus 94 degrees Fahrenheit, high enough for stable oceans of water-ammonia mixtures to exist on its surface. As the Sun's ultraviolet output decreases, the haze in Titan's upper atmosphere will be depleted, lessening the anti-greenhouse effect on its surface and enabling the greenhouse effect created by atmospheric methane to play a far greater role. These conditions together could create an environment agreeable to exotic forms of life and will persist for several 100 million years. This was a sufficient time frame for simple life to evolve on Earth. In early 2020, NASA's Transiting Exoplanet Survey satellite, TESS, discovered an Earth-like planet named TOI 700d in its star's habitable zone, and is only one of the few that exist where conditions may be just right to allow the presence of liquid water on the surface. However, until more measurements are made, the exact conditions of this planet are unknown. This is where the James Webb Space Telescope will come into play. This telescope is supposed to launch on March the 30th, 2021, and will provide improved infrared resolution and sensitivity that's far greater than the Hubble telescope. At a cost of $10 billion, it's one of the most advanced telescopes ever built. Its expensive mirrors covered in pure gold. The James Webb Space Telescope will be able to image even the most distant events and objects in the universe, such as the formation of the first galaxies, and it's believed that there will come a day where NASA will find a planet just like ours, flourishing with life. Scientists have been finding exoplanets that could be potentially habitable for some time now. There are hundreds of millions of them out there, and more found every day. There isn't a planet like ours anywhere in the universe that we know of. But now scientists say they have found exoplanets that could be more habitable than the Earth. But do they really exist? An exoplanet, or extrasolar planet, is any world that orbits a star outside of our solar system. Exoplanets can range in size from gas giants larger than Jupiter to small rocky planets like Mars and Earth. Most of the planets that have been discovered lie in a small region of the Milky Way galaxy, and we know from observations made by NASA's Kepler Space Telescope mission that there are more planets than there are stars. The first exoplanets were discovered in the 1990s, and since then we've discovered thousands more using several different methods. But it's not an easy task finding them. There could be at least 300 million potentially habitable exoplanets in our Milky Way galaxy alone. The US Space Agency's Kepler Space Telescope spent 9 years on a planet-hunting mission and identified thousands of these exoplanets in our galaxy before it ran out of fuel in 2018. After going through all the data Kepler collected, those 300 million rocky planets could be capable of supporting liquid water on their surface. This is just a rough estimate, as there are between 100 and 400 billion stars in the Milky Way, and every one of those stars probably hosts at least one planet. That means there are likely trillions of planets out there. You may think it's as simple as using a telescope to find them, but it's rare to see an exoplanet the way you would see Saturn from Earth. This is called direct imaging, and very few exoplanets have been found this way. Most exoplanets are found by using the transit method, which measures the dimming of a star as a planet passes in front of it. We can also find exoplanets by measuring the star's light spectrum for signs of a planet pulling on the star, causing the light to shift, or finding them using gravitational lensing. Using all these together is allowing us to find more exoplanets every day in the vast universe. If we're going to look for exoplanets that could support life as we know it, the first place to look are planets that orbit their host stars in the habitable zone, or what some scientists call the Goldilocks zone. This is the area around a star where it's not too hot or too cold for liquid water to exist. But the planet also has to be the right size, and the type of star that the exoplanet orbits has to be a certain type, and it should be stable. Our own sun, a yellow dwarf, has had a stable existence for over 4.5 billion years. But this is not always the case for different stars in other systems. But we'll talk more about different types of stars in a moment. First detected by the HARPS telescope in 2016, Proxima b is the closest alien exoplanet to our solar system at 4.2 light-years from Earth. It lies in the habitable zone of its red dwarf star, Proxima Centauri, and was thought to be a minimum 1.3 Earth masses. But a new telescope named Espresso recently discovered Proxima b to be only 17% more massive than our planet, making it more Earth-like than had previously been thought, and a candidate for life, because it's the right distance from its host star to have liquid water. Scientists believed that the planet could be habitable, and future generations of superfast spacecraft could travel to the planet in search for life. But that same year, a massive solar flare had erupted from the red dwarf star Proxima Centauri that was 1,000 times brighter than the star itself. It hit Proxima b with 4,000 times more ultraviolet radiation than the Earth would get from a solar flare from our Sun, and researchers believe that this could have wiped out all traces of life on the planet. But Proxima b is not the only candidate as a habitable planet. Scientists now say they've discovered 24 super-habitable planets or exomoons that could be better suited for the emergence and evolution of life. The concept superhabitable came from two researchers in 2014. René Heller and John Armstrong have stated it takes much more for an exoplanet to be habitable than just being in the habitable zone. Things that would make a planet more suitable for life as we know it means they could be older, larger, warmer, wetter, could have higher levels of oxygen, and a longer living star. Heller and Armstrong have proposed that the required size of a super-Earth would have to be 2 Earth masses because radioactive decay in the planet's interior would last longer to provide heat, and the stronger gravity would hold on to the atmosphere longer. These 24 super-habitable exoplanets were chosen because they have a star of the right size, lifespan, and lie in the habitable zone. Many of these orbit around G-dwarf stars similar to our Sun, but researchers also looked for exoplanets orbiting around K-stars, orange dwarf stars that are cooler, less massive, less luminous, and there are 50% more orange dwarfs than yellow dwarfs in the Milky Way. While these Sun-like stars might not sound ideal for life, they have a big advantage. Their lifetimes are anywhere from 17 billion to 70 billion years, compared to the 10 billion year lifespan of our Sun. If life started on a planet orbiting a K-star, life would have had much more time to evolve than life on Earth has so far. Considering it took complex life 3.5 billion years to evolve on Earth, and 4 billion years for advanced life such as humans, a larger size exoplanet could mean more space for landmass and habitat. These superhabitable worlds would also have a higher gravity and a thicker atmosphere, allowing beneficial organisms to travel through the air, spreading life. Planetary scientists say the sweet spot age of a superhabitable exoplanet is about 5 to 8 billion years. Of course, a more superhabitable planet would need water for life as we know it to survive. Planets with more moisture and an average surface temperature 8 degrees Fahrenheit warmer than Earth could make them more habitable, since we understand there is more diversity of life in warmer and wetter climates. Some of these more habitable planets could resemble the Earth in the early Carboniferous period, about 359 million years ago, when the planet had the climate of a tropical rainforest. Gliese 667cc is the next closest superhabitable exoplanet which orbits a red dwarf star in the Gliese 667 triple star system. Yes, 3 stars. If you were standing on Gliese 667cc, this is likely what you would see in the day sky. Gliese 667cc lies 23.62 light-years from Earth and is a minimum of 3.7 Earth masses. Another possible superhabitable world could be Kepler 452b. It's sometimes called Earth 2.0 and orbits a G-type star, which is very similar to our Sun, except that it's 1.5 billion years older and slightly bigger. Some authors speculate that there could have been an ancient civilization on the exoplanet or the Moon orbiting it. But it's possible that we're now seeing a glimpse of the future fate of Earth, because the star it orbits used up its fuel and has expanded into a red giant. But there are other things that we should be looking for. So far, there has been no way to detect oxygen in an exoplanet's atmosphere. But soon things will change. On October the 31st, 2021, the James Webb Space Telescope is scheduled to be launched into space on an Ariane 5 rocket. The technology on the telescope is unlike anything ever designed. It's the successor to the Hubble Space Telescope and will be a powerful new tool in the search and study of exoplanets that could support life. The James Webb Telescope will move out 940,000 miles away from the Earth, well beyond the orbit of the Moon, where it will set up shop and orbit the Sun. It'll be the largest observatory ever sent into orbit and will use special cutting-edge optical science and engineering to peer into the unknown. Researchers say they've developed a new technique that will allow the James Webb Telescope to detect a unique signal produced when oxygen molecules collide. If this signal was found in an atmosphere of an exoplanet, that would mean it would have oxygen, and perhaps life as we know it, present on the planet's surface. Despite all this amazing technology, if a planet orbiting a red dwarf has an atmosphere similar to Earth's, it will need to be within 16 light-years for the Webb telescope to detect the oxygen signal. After its 2021 launch, the James Webb Telescope will study the history of our universe, including distant exoplanets, other galaxies, and the first luminous glow of the Big Bang and the evolution of our solar system. But we may need something more powerful to look farther out into space. The Nancy Grace Roman telescope will be launched sometime in the later 2020s and will have 100 times the viewing field of the Hubble Space Telescope. It'll probe the depths of dark matter and dark energy, the mysterious and mostly unknown phenomena that makes up most of the universe. The most exciting thing is it'll be able to make direct images of exoplanets, something not possible from planet Earth. But the main goal of its mission is to peer into the interior of the Milky Way galaxy, where it would possibly find thousands more exoplanets through gravitational microlensing. But if we do find life out there, we must remember the universe is fascinating and very diverse, and the best place for life, such as superhabitable worlds, might not be like Earth in any way we traditionally imagine. We're entering a very exciting time in human technology, and with the number of habitable worlds out there, it's likely that we will finally discover life on a distant world.